Once you've written an equation, it is now time to use it to maybe answer some questions that you have some interest in. Let's see what we have here. I covered up some information. Let's uncover it. So given the situation we set up the equation for in the previous part of the lesson, we're now asked specifically, all right, well, what's the value of the car after 9 years? Well, let's see. If I'm going for a 9-year difference, we're just going to put a 9 in where this t is. So the amount the car is worth, or the entire fleet rather, is going to be 29,900, our starting value, times 0.894 to the power, excuse me, of 9, since we're going for those 9 years. At this point, I'm going to head right over to the calculator. I'm using the handheld. You can use Desmos. It'll give you the same result. So starting amount times the multiplier to the power. Make sure you're using the exponent button here above the divide of 9 years. Now, this is a money problem. We're talking dollars and cents. So let's round to the nearest hundredth, the nearest cent. So $10,907.09 is our value at the end. $10,907.09. Now we have answered the question, but I want to do just a small amount of investigation so we can see what's happening here over time. So in this situation, I think I want to look at not all 9 years at once, but how about just the first couple of years so we can see what's happening. After just 1 year, your value has gone down from $29,900 to $26,730.60. How much did we lose? Well, let's take the starting amount minus the ending amount. So over the course of that 1 year, the value dropped by $3,169.40. That's a pretty big leap. Let's see what happens, though, from year 1 to year 2. So let's bear in mind, after year 1, our value is now $26,730.60. Let's do that same multiplier again. So we're losing 10.6% of value. We end up with a car that is now worth $23,897 and about 16 cents. How much value did we lose in that second year? Well, take our starting amount. So at the beginning of the year, it was worth this much. At the end of the year, it's worth this much. So we lost $2,833.44. Notice that in the first year, we lost almost $3,200, whereas in the second year, the value went down only about $2,800. Still a drop, but not by as much. That's because when you take 10.6% off a smaller number, you take less away. So even though the percentage stayed the same, the actual amount of dollars is going to be fewer and fewer each year as we go. So value always goes down, but it goes down less quickly. That's where we get that exponential decay curve. How about just a little more practice? Given a situation, we're going to work together to write an equation and then use it to answer the question that's asked. So take a moment and read this through. Let's now take a look at the important information. So first, you do need to understand what the words mean. So a savings account balance is compounded annually. This means that the balance goes up. We're looking at an increase. If the interest rate is 4.8%, okay, so that's going to matter per year. And the current balance, so the starting balance, that's the amount of money. Balance is the amount of money in the account, is $1,363. What will the balance be in 7 years? Okay, so that 7 is going to matter as well. When you're setting this up, start with your equation in general form. It's going to be the ending amount is the starting amount times your multiplier to the power of t. Now let's fill in what we know. I don't know the ending amount. That's what we're after. So leave that as an A for right now. Starting amount, that's going to be the $1,363. For the multiplier, we're going to think about that for a moment and come back to it. The amount of time we know is going to be that 7 years. All right, now let's talk about the multiplier. So we've got 100% to start with. Always start with 100%. We are increasing, so a plus by 4.8%. So put that together, I've got 104.8%, which as a decimal would be 1.048. Always move that decimal back 2 spots to turn it into the multiplier. Okay, let's throw this in the calculator. Again, it's money, so let's round our answer to the nearest cent. 1363 times the multiplier for 7 years. So we're going to end up with $1,892.45. 1,845. Oh, I've already forgotten what the number was. $92.45. All right. Now, this is actually the way money works. I don't know if you've ever heard the expression, it takes money to make money. This is what it means. When you have a percentage that your investments or your savings increase, that means if you have a larger starting amount, then each year you get a larger increase in dollars. So if you have a small savings account, say with $100 in it, and you go up by 4.8%, well, that means you get an extra $4.80. But if you have a savings account with $100,000, oh my goodness, well, then you get 1,000 times as much as you go up. You get $4,800 as you go with that same percentage rate. I don't want to burst your bubble, but it turns out that if you go to an actual bank and have just a savings account, your interest rate is never this high. I think my current interest rate on my savings account is something like 0.02%. It's a very small number, so it's not really a way to get rich. Let's do a recap, and then we'll look at one more. Always start with your same template. Ending amount is starting amount times the multiplier to the power of time. Fill in the information you know so you can solve for the information you don't. Take a moment and read through there. So we've all done this, right? You dropped a ball, and so if you start, the ball bounces back, and then it bounces again, and it bounces again, and it bounces again, but it keeps bouncing smaller and smaller amounts each time. This is going to be a decrease, an exponential decay situation. So let's see what information we have. We're told that our starting height is 106.00 inches. After each bounce, the ball returns to a height that's 15.2% less. Okay, so there's another reminder. The fact that it says less means we're looking at a decrease than the previous maximum height. What is the maximum height after the 7th bounce? Okay, that 7 is going to matter for us as well. So this time we're measuring time based on number of bounces. Okay, I want you here to try your best. Do a pause on the video and put in all the information you think we should have, and then do an unpause when you're ready to check things. And we don't know the ending maximum height, but we do know the starting maximum height. It's this 106 inches. The multiplier, we're going to think off to the side here in just a moment. And the amount of time, this time we're measuring how many bounces, so we'll go to the 7th bounce. Now let's take a look at the multiplier. Always start with 100%. It's a decrease, so we'll use a minus. 15.2%. Let's see what that ends up with. So 100, take away the 15.2, leaves us with 84.8%. which has a decimal. It's going to be 0.848. 0.848. So each time the ball bounces, it loses 15.2% of its height. That means it's going to keep 84.8% of its height. Let's throw this now into a calculator, either Desmos or the handheld. So 106 inches for the starting height. The multiplier, 0.848. And we're going for 7 bounces. Now, if you're not sure where to round, just include all the decimals. I'm going to round to 2 decimal places, and I'll tell you why. So 33.4, because after the 2 is a 5, I'm going to round that up to 43. So 33.43 inches. So include your unit, like here we included the dollar sign, here we'll include the inches. And the reason that I went to 2 decimal places is because look at the initial height they gave us. Do you see how that had 2 decimal places? So I'm just matching the level of precision that we were given in the problem itself. But like I said, if you're not sure and it doesn't say, just include as many decimals as you can. So recap the process, and I think we're going to be good. Start with your template, fill in your starting amount, calculate your multiplier, and we're going for 7 bounces. Throw that in the calculator and see what comes out. Make sure this makes a little bit of sense. I do know that after 7 bounces, I should be down much lower than I was when I started. So from 106 to 33, I think I can trust my result is reasonable.